In the previous video, we learned how to sketch the graph and find domain and range for rational function. In this last part, in this video, we discuss a piecewise defined function. A piecewise defined function is a combination of two or more functions where it will separate with the value of s that define its function. So the first one and the third one, the first one is a negative x. So negative x is a linear. So for linear, we know that for negative, it will be negative gradient. And basically, in order to sketch a linear function, you need to plot 2 points. So let's say xy. So the first one is negative 1 itself. And the other one, so let's check it here. Since x less than or equals to negative 1, so you need to find out the value of x which is smaller than negative 1. So let's say negative 2, right? So substitute these two values of x into the function negative x. So negative 2, so the value of y would be 2. And negative 1, so the value of y would be 1. Right? So the point, when we want to sketch, so we sketch like this. So we plot the x and y axis. Right? So this is the point. So here we have negative 1, negative 2. So here 1, 2. So plot it like this. So for the first function, the function start with x less than negative 1. So straight line towards negative 2 and a little bit more. So at the end, we could put an arrow to show that it will continue for the x less than negative 2. Right. So done for the first piecewise. So look at the second piecewise. So the second piecewise is x squared. So x squared in this case, it is a quadratic. So remember, for the quadratic, we need to find out the minimum point first, right? So compare with the standard equation of quadratic. So nothing of x and constant apart from x squared. So automatically we will consider that the minimum would be 0, 0. Right? And then find out the value of x that define the function x squared. So it is between negative 1 and 3. So for negative 1 and 3, you also need to find out what's value of y at when x is negative 1 and 3, right? So you need to find out. So put the table also like like this. So we already know when x 0, y 0. So when x negative 1, so negative 1 squared. Squared means that it will be positive, right? So it will be positive 1. And then 3 squared, so it will be 9. So we can plot right here. So 1, 1, okay, no problem. 0, 0, and then 3. So let's say 1, 2, 3, and then this one 9. Oh, so 9 should be above here, right? And then we join the function. So remember, this time it is a quadratic. Remember the shape of quadratic? The shape of quadratic like this, right? So since it is 0, 0, so negative 1, 1 will be here, and 3, 9 will be like this. So abandon this, so it will be the shape will be like this. So the first one, so put it a little curve right here. Okay, and then like this, and then we join like this. So make sure it is a big curve because it is quadratic. And also here, make sure not straight line, a big curve until here. So I hope you can sketch better than me. Make sure it is a quadratic type. Okay, and then lastly, x plus 1. So for x plus 1, again it is a linear function, and this time since x is positive, so we get a positive gradient type. Okay, and also we know that x defined for greater than 3, so we plot the first one 3 and the second one, let's say 4. So after 3 is 4, right? So substitute when x3, 3 plus 1, so y is 4, and then for x equals 4, so 4 plus 1, it is 5. So you can plot like this. So y3, 4, okay, so something like this. When 3 is 4, when 4 is 5, okay. So it is a so since it is 2 points like when x equals to 3, and this one is 4, so we check the equals 1. So the equals 1 is at 3. So remember, so this one we will put a dotted here because it is included, the dense circle. See, this one no problem because it is continue at the same point. But here you start at below, when 3 x y 4, when 4 it is 5. So your graph, so you need to empty circle and then a straight line towards here, and then we continue and put an arrow like this, right? And then lastly, don't forget to label x and y axis. So generally, if I sketch again, maybe I will sketch again in the next slide to make it clearer. Okay, I sketch again right here. So 9, and then 5, 4, 3, 2, 1, and x-axis right here. So this is x, y, and then here -1, -2, and then here 1, 2, 3, 4. So the previous one, remember the shape of the graph. So 1 here included, and also towards here. So the graph straight line with the magnetic gradient, and then the second one, it is quadratic, and when x equals 3 it is 9. So remember the shape of the graph, the quadratic is like this. So a big curve here, and then here, let's say I start from here, okay, and then another one when x equals 3, begin at 4 and we start at 4, it is 5. So the last one, the straight line would be like this. Okay, so this is the graph from our example, and the question here is, what is a domain? So remember the domain where the function is valid for the value of x. So check the graph. Less than, it is defined, and then it is continuous here towards here. Okay, and then two separate value but still defined when x equals to 3, and then continuous again to the positive value. So here we can conclude that for the domain in this piecewise function, it is all real numbers, right? And how about the range? So remember, the range is y, right? The value of y. So as you can see here, the lowest point here is at minimum point, which is right here. And let's check the left one towards the negative value, so to the positive value. The same also here towards the positive value. The lowest point here at 0, right? So the range would be 0, infinity, right? So this is how we sketch the graph, and from that we find out the domain and range for piecewise function. I know that some of you may be a little confused, but remember the process and then do a lot of exercise. I'm sure that you can sketch the graph and find domain and range correctly. So that's it for subtopic 5.1e. Thank you.